Right, brilliant. We are live. Good. Right. Before we start the lesson at 11 o'clock, I shall just check. I've got my settings sorted. Yeah, brilliant. Okay, good. So, right. Okay, welcome everyone. I need you to write your name next to your profile because I don't know who you are, obviously. And let's keep it clean, please. I've got moderators in this form, and I've also got the automatic the automatic YouTube filter switched on. Right. Okay, I'm gonna. Right, brilliant. Hello, Ellie. I'm gonna just check my settings. So hopefully now you'll be able to see me full screen, and then we can start the lesson shortly. So I won't start till 11. So brilliant. Hello, Lydia. Spot on. And hello, Harvey. And hello, Ella. Emily Shaw. Good. So we've got some people getting ready for the lesson, which is good. I hope everyone's doing fine. I'll leave the live chat on while I do a welcome, and then I'll disable it for certain parts of the lesson. All right. So let me see where we are. Good. Okay. Hello, everyone. Let's have a look. Morning, Harrison. Morning, Corinne. Morning, Sophie. Morning, James. I'm still not sure about who Off and Boff is. Right. Has anyone seen Matthew? Because I need to set Matthew as a moderator. So if you just put a message on Matthew, if I don't get Matthew by 11, James, I'll set you as a moderator to do something else. And well done. I've said to the moderators to block anything or ban anyone who isn't focusing on what we're doing. Brilliant. And Matthew, you've stayed as a moderator, so that's good. Right, excellent. 3 minutes to go, and then I shall see what I can do to start this this lesson. All right. Okay. Good. Hi, Aiden. So I was going to say, if XQC needs many more messages deleting Coco, just all right, brilliant, fantastic. You've done it already. Thank you, Kirby. Right, 2 minutes to go, folks. Hello, Taylor. You all right? Good. You'll notice what I'll do is I'll put. Oh, well, I won't explain that now because I'll explain that to everyone. But if I go that, you should now be able to see that I'm looking at the chat. So if you there's hi Chloe. There's only any point putting comments on for me specifically if I've got the screen showing as it is now, because if it's not showing as it is now, let's have a look. Yeah, if it's not showing as it is now, I'm not looking at the chat, and so I won't reply. I won't be typing anything to reply. I'll be answering questions through the live stream, and I need a watch so I don't get mixed up with what time it is and where we're at. Okay, so yeah, you can tell I'm looking at the live stream at the minute because it should be on the feed that I'm looking at it, as opposed to that where it's just me chatting. So if you message me now, I won't see it because I'm not looking at it. I'm only looking at the feed when you can see that screen, if that makes sense. It does to me anyway. Right, are we looking for time before we start? Not too bad. Right, good. Is that refreshing or does that not refresh? Let's have a look. Right. Yeah. Alex, I agree. Hey, Miss Backhouse, hello. We have a TA on. Excellent. Good to see you, Miss Backhouse. Hi, Lauren. Hello, Ashley. Good. All right. I think we need to make Miss Backhouse a moderator. You can just enjoy this lesson, Miss, and help me out if it all goes badly wrong. Hello, Lauren. Right, good. Okay, it's 11 o'clock. So what we're going to do is we're going to make a start. All right. So hello, everyone. I hope you're doing all right in this lockdown. It is hard work. I know that for sure. I'm not going to talk too much about anything like that because this is like a lesson. It's as if you are now in a virtual classroom. I think this is the first ever live streamed lesson from Furnace Academy, so that's good. So we've got a first, and so I'm just going to go straight into it. I wanted to speak to you about a couple of things, okay? Firstly, I wanted to speak to you about the live chat. The live chat is being moderated. You will be blocked if you put anything inappropriate on there, and it will be removed. You'll also be timed out for 5 minutes if you start chatting between yourselves, because you can do that on your WhatsApp groups and everything. This is about learning some stuff, so I'm trying to deliver a lesson like it would be if you're in the classroom. I'm extremely nervous about this because you have to juggle from a teacher's. It's a completely different way of teaching, and you get no live feedback, so you don't know if your screens are all blank now. You just have to assume that it's working. So I'm extremely nervous, so bear with me. Yeah, so the live chat's being moderated. We've spoken about that. I'm going to switch the live chat off at certain parts of the lessons when you need to be concentrating, and I'm going to switch the live chat back on when we say like, any questions, anyone? How are we doing so far? And then I can give you feedback on how that's gone with and then I'll disable live chat so we can focus on what we're doing. So it'll be enabled and disabled through the live stream. But let's use it properly because it's great to have it as a facility, but we need to use it properly. Okay, excellent. Secondly, I sent a sheet through that looks a bit like this. So hopefully now you can see a document that I sent through with some key knowledge that needs to be learned, and then. Yeah, if I scroll down through it, some tasks for you to do as we go through this lesson. Okay, now if you don't have this sheet, don't worry, because I've put things on the PowerPoint, so you just need a pen and paper. Okay, so hopefully, ideally, you'd have the sheet and you'd be filling it in, but otherwise you can do things on pens and paper. Okay, right, good. So before I get on to what we're learning about, we are going to have a quick quiz. Those who I teach know that I do a quick quiz at the start of every lesson to see if we can remember what we've done previously, etc., etc. So I'm going to give you some questions. So now, if I switch to the PowerPoint, okay, and you can see the PowerPoint, and we will have a look at what we are doing. So, pen and paper ready, folks. let's have a look at this morning's quick quiz. It's like being in school, isn't it? You're all groaning. Right. Question 1, please. Just so you should be jotting these down, pen and paper, just writing down your answers, and then just like in class, we'll go through them quickly. So this is the stuff that the year 11s who are joining me have already done, and the year 10s who are here, we've done the energy unit, we've done the electricity unit. So a little bit of particle model unit. So these are questions that should jog your memory of stuff that lead us into what we're doing today. So what are the units of energy? Question 1. Question 2. What store of energy is to do with the movement of an object? Okay, so what store of energy is to do with the movement of an object? What I'm going to do is right now I'm going to let's have a look. I've disabled the live chat so we can focus on we can focus on the quiz, and then we'll come back and I'll enable the live chat again in a bit. Okay, so live chat switched off, so we need to focus on this quiz. Right, question 3. What is the formula for gravitational potential energy? Right, so I want you to write down the formula for gravitational potential energy. This is just low stakes. Doesn't matter if we get these right or wrong, but we try and get our brains into gear. So what is the formula for gravitational potential energy? And question 4, what is the circuit symbol for a fixed resistor? All right, so I'll give you a couple of minutes just to jot the answers down before I give you the next 4 questions. Right, good. I've also just had some old school technology through from Joanne Smith saying she's watching, but she hasn't got a clue how to do something or other. Joanne, keep going. You'll work it out. I can't help you now because my brain's absolutely full to brim at the minute. All right, let's get back to this quiz. So here's a picture now. We've all of year 10, obviously year 11. We should, I think, Miss Ivy's classes, Miss Kitchen's classes. We've all done stuff on the particle model of matter, and you've been doing this stuff since primary school. All right, so what I want us to do is look at this, get a recap, and then remind ourselves. So there's questions about this. So this is the standard particle model of matter. So these red things here, I hope you can see my cursor, highlighted. These red things here are particles. All matter's made up of particles, and we've got these 3 different states of matter. So question 1, which letter represents a liquid? So A, B, C, D, or E, which letter represents a liquid? Question 6, because we've done 4. What is the changing state called represented by the letter D? Okay, so you can see here there's a change in state. So it's going from one state here, where it's represented, to another state here, where it's represented by E. So what's this changing state called when it goes from C to E? A couple of things just quickly while you do this. If you look, it's a good diagram, this, because the number of particles have stayed the same. When you change state, when you go from the different states, either direction, either adding energy to go the way these arrows are going. So we add energy to A to turn it into C, and then we add energy to C to turn it into E. there's something called conservation of mass, where when we change state in a fixed system, we're not going to lose any mass. There's the same number of particles that we start with as that we end with. So if you turn a solid into a gas via a liquid, at each stage there is the same number of particles and they're the same size. Just a couple of things change with them. Okay, so question 7. Which letter represents a substance with the most energy? A, C, or E? B and D aren't substances. Which one represents the substance with the most energy? And finally, question 8. What two quantities make up a substance's internal energy? That is a bit of a more tricky question. But hey ho, some questions are harder than others, aren't they? That's how it works. Okay, so those are your quick quiz questions. I'll show you. Well, I'll tell you what I can do with this. I think I'm going to go through the answers shortly. So just while you're getting your answers down, just quickly. In fact, I'll switch back to PowerPoint mode so you can see the first 4 again. We're all at different levels, aren't we? All right, so this is one huge virtual class, and we're all at different levels. So what I'm going to do is, and I'll talk more about this after the quick quiz, this is the stuff that I'm going to teach you, the stuff on the specification that everybody needs to know, okay? I'm going to clearly indicate what's higher. I'm not going to do a live stream for foundation, a live stream for higher, a live stream for triple, a live stream for combined. It's just one live stream, but I will clearly indicate to you which stuff is higher and which stuff is foundation, okay? And I'll clearly indicate to you, most of our students are doing triple science. So most of you lot, and you'll know if you're not doing triple science, okay? So everyone needs to just try and crack on and learn as much of this as they can, okay? If you are doing foundation, don't worry about the higher stuff. And I'll also give some extensions at the end to try and stretch some people, because I'm not going to limit to say, right, okay, only you lot are going to get this stuff to have a go at, because everyone should be able to have a go at it if they want. The main thing you need to do, though, is work through the objectives. Right. Enough waffle for me. Let's see the answers to this. So, I'll put the live chat back on in a minute to see how people got on with the quiz. But I'll just go through the answers on the PowerPoint, okay? And then we'll see how we've done. So, units of energy, that is joules. Energy is measured in joules, okay? What store of energy is to do with the movement of an object? Kinetic energy. Okay, so kinetic energy is to do with, is the energy store to do with an object that's moving. If an object isn't moving, then it doesn't have any kinetic energy associated with it. Okay, if it's moving really quickly, then it has more kinetic energy. So kinetic energy associated with an object moving. Formula for gravitational potential energy. Hopefully some of you could remember this. GPE is mass times gravitational field strength times height. Okay. And then that's the symbol for a fixed resistor. So well done if you got those right. Right, here we are, our model of a solid, liquid and gas and some transitions. C represents a liquid. Now you can tell that because in our solid here, the particles are close together, but they're in a regular ordered structure. Okay, see, this is a regular ordered structure. And these particles can't move position. They just vibrate around a fixed position in a solid, okay? In the liquid, which hopefully you quickly identified as C, these particles can now switch position. Can you see how they're still touching, okay? But it is not... lots of people make the mistake of saying in a solid, oh, the particles are just a little bit far apart, or there's a little gaps between them, okay? The particles are still touching. It's just they're now in a random order because they can switch position. Because they can switch position, there is more space in between the particles because they're jumbled, okay? Nice and neatly ordered in our solid. They're absolutely, there's very little space because it's an ordered pattern. Solids keep their shape because the particles in a solid can't change position. They vibrate around a fixed position. Okay, and this is our liquid. Of course, in the gas, they can fly off anywhere they want, and then they aren't touching. Okay, but they collide with each other. So, changing state is boiling or evaporation. Okay, and there is a subtle difference between boiling and evaporation. So, I'm not going to go into it here. When you change from a liquid to a gas, it's called boiling or evaporating. Challenge for you lot who wants a challenge. Email me, explain to me the difference between boiling and evaporation. I know it, okay? Both processes lead to the changing state between a liquid and a gas. But what's the difference? So there you go. That's for anyone here who fancies an extra challenge, higher task. What's the difference between boiling and evaporation? Okay. Letter E, the gas represents the substance with the most energy. Gas particles move faster, okay? They fly around really quickly, okay? They're also more spaced out, which gives them more potential energy, because the energy in a substance, the internal energy in a substance, which is the next question, is the sum. So how much kinetic energy the particles have all got as to how they move, and how far spaced out they are, which gives them additional. The more spaced out they are, the more potential energy that they have. Okay. So the gas, because the particles move faster and they're more spaced out, they have more potential energy and more kinetic energy, so they've got more internal energy. That's why E is the substance with the most energy. Okay. Right, good. Quarter of an hour for the quiz. That's a bit longer than in lessons, but doesn't matter. What I'm going to do now is switch live chat on, and you tell me how many you got. So if I go control, you should be able to see me enabling the chat now. Allow live chat rate to replay. Why not? I might regret that. I don't know. But, so now let's see what I would like. What I would like you to do is put up on here your scores for the quiz, please. Sophie Milburn, legend. Right, on it, 7 out of 8. We've still got our brains. The lockdown has not melted our brains. Good. Course, full mark. Kira, brilliant, legend. Blooming it. Coke and Spazies. They can moderate a chat and do the quiz. Oh no, the chat was switched off on it. Right, good. Ella, there's a shock, you got 8. Right, good. 8, folks. Connor Bentley, legend. Oh, Sky's in here. Right, good. Gypsy, another shock. Right, folks, this is awesome. If you are getting over, hey, we're crushing it. I'm hoping. Poppy, brilliant. It was out of 8, but it doesn't matter. I guess you missed the first 2. Emily, awesome. Could we have some real names for Papa Spice? Right, awesome. Jake, brilliant. Right, good. Ben's right. We're in trouble. Benjamin Patel's in the house. I need to resign now. Right, you need to check my content, Ben. Make sure I'm talking the truth, mate. Beth, right. Hey, you lot. This is sensational. This is it's working. So all this messing about stuff on the computer that I don't really know much about is actually working. Melanie, fantastic. Right. Hey, good. So you lot are brilliant. Very interesting, Huff. Right. Okay. We're going to go back to the PowerPoint. So, I think. So what I'm going to do is I'm going to knock. You should be able to see this. Folks, well done. I'm going to knock The live chat off. Brilliant. So now, and then I'll go back to the PowerPoint. If I can. Right, and I'll check on my OBS just because I'm new to this, whether you can definitely see me. What's it? Oh, of course you can. I need to stop doubting myself. Right. Okay, these are our learning objectives for today's lesson. All right, and I'm going to try and keep this live lesson to an hour. Describe the structure and properties of the atom and its constituent parts. Now, this underpins a huge amount of this topic and a huge amount of your chemistry. To a lesser extent, the biology, but understanding what an atom is actually made of, rather than just this particle that we've been talking about, what these atoms actually are is hugely important. Okay, so we're going to start there. Excuse me. Then what we're going to do is we're going to look at, once we understand what an atom is, we'll look at how we describe an atom using its mass number and its atomic number, and how we can interpret an atom based on the information that we're given about it. Okay, so if we get a symbol from the periodic table displaying some information about an atom, what does that information tell us? What is a mass number? What is an atomic number? Because these are the ways that we describe an atom. So we'll look at what an atom is, then we'll look at the key indicators for describing it, so the mass number and the atomic number, and then we'll look at something later on, which is an isotope, and we'll see how isotopes work, okay, and what they are, and then we should have bossed it. So good, let's crack on. Now, we're going to start by looking at the structure and property of the atom. In a minute, you people work in different ways, and it'll be totally interesting to see how you work alongside these live stream lessons. On your sheet, so if I switch to the sheet that you should have been given, so if you didn't print it out, don't worry, because it should be on your screen now. If I've done it, sorry. The start of the sheet, and I'll do this for each lesson that I send, is some key knowledge, and this is the knowledge that you need to learn. Now, you'll notice that the image that I'm showing on the PowerPoint is there in that key knowledge for you, okay? So I'll talk you through it, but it's there for reference, okay? All of the key bits of information that will help you with the questions are there in that key knowledge. I've structured it as a table, so so you can cover one side up. You can cover half of it up, and you can test yourself, and you can quiz yourself. So, for example, you can look at the left hand side and say properties of a proton, and then you could see if you could remember that it was a +1 mass and a +1 charge. Okay, so it's done as a sheet, almost like a knowledge organizer in a sense. So you can work through them. So hopefully that makes sense. So all the way through these tasks, use that information on the sheet that I sent you out. It is there to help you. Okay, good. So back to this. You can see this blue circle here, right, which is like the particles that I showed you in the earlier picture part of the quiz in terms of solids, liquids, and gases. Now, when we're talking about atoms, okay, they're not just solid blocks of stuff, solid blocks of matter, okay? They are made up of 3 parts, basically. They call them subatomic particles, but these are 3 parts that an atom is made up of. Now, for some of you, this will be revision, and you'll know this inside out. But for some of you, this is where you really have to get hold of it. I'm just going to shut that door because someone's over it. Okay, so we're going from an understanding of a particle as just a solid object up through to actually the structure of an atom, including what these 3 particles are: the electron, the proton and the neutron, where they live, and their properties. Okay. The second live stream will look at how scientists got from this model of an atom, basically, up to our understanding today of the actual structure of an atom. And it's not just a solid little lump that's very, very tiny. These things are super tiny. You can get 4 million atoms in a grain of sand. They're ridiculously small, okay? But we in our next live stream, we'll look at how we go from this to this, and that included the investigative work and the discoveries of J.J. Thomson and Ernest Rutherford, amongst others, because we need to know how we arrived at this model from this model. But today, we're just trying to remember this model. That's our key learning objective. So we have electrons that orbit the atom, the nucleus of the atom, which is the nucleus, which means the center part. Okay, so you've probably come across the word nucleus before in the cells topic, because cells, nearly all cells have a nucleus. Nucleus in terms of atom just means the central part. Okay, now this is where most of the mass of the atom is. All right, the proton, it's made up of two little particles in the nucleus. Okay, there's protons, which have got a positive charge, and there's neutrons that have got a neutral charge. They've got no charge. Now going round the outside, okay, we've got electrons in different shells, different energy levels. Okay. And they have got a negative charge. Okay, so here's an electron with a negative charge. So we need to remember, protons are positive. Okay, they're found in the nucleus. Neutrons, neutral, no charge. Again, found in the nucleus. The proton and the neutron have a mass, a relative mass of 1. Okay, the electrons, in comparison, have got a very, very, very small mass. It's 2,000 times roughly smaller than the mass of a proton. So we say it's pretty much zero, approximately zero. So the electrons don't have much mass. The vast majority of the mass in an atom is in this nucleus, where you've got the proton, which is +1 mass, a neutron, which is +1 mass. Sorry for swearing at you. And electrons, which are much less massive. We sort of ignore their mass normally. Because, yeah, compared to the middle, it's not a lot. So the nucleus is positive because you've got protons that are positive and neutrons with no charge. So this nucleus is positive overall because of those protons. And these electrons go round the outside. Okay, good. So this model is the one that we need to know. What it's made of, the 3 particles, and their properties, their charge, their mass, where they live. Okay, good. Right, I'm going to turn chat on, and I want you to have a go at filling in this on your worksheet. If you haven't been able to print the sheet out, what I'm going to do is I'm going to leave that screen up, but I will be looking at the chat, so you can ask me for any help on those questions. Just give me any feedback on how things are going, because that's one of the things with these live lessons you struggle for in terms of feedback. But yeah, have a go at that task now, please, while I switch the chat. And once the chat goes live, I will be looking at my chat, but you'll be able to see this in case you've not got the sheet, because you can just jot this down on rough paper if you want, if you haven't got the sheet printed out. Okay, let's have a look. So I'll leave you lot there. So you should still be looking at the PowerPoint, though I'm not. And okay, so you're looking at the PowerPoint for people who haven't done it. Brilliant. So Connor's already finished that. I imagine you won't need much time, right? Good. Right. Excellent. Right. Good. I don't know if that's sarcasm, Black Sabbath. Probably. But is everyone done? Just give me a thumbs up in the chat if everyone's done. Okay, or if someone needs help, yeah, I know some of you could. That's why we're doing it as the first thing. I appreciate the feedback, Hoff and Bob. I know, but we are catering for everyone here, okay? And we need to make sure we have the fundamentals. All right, good. We look like we're crushing this, so I'm going to move on. Remember, you can always, once this has been uploaded, because we're on 1:30 now. Brilliant. Good. We're done. Excellent. Right. So if you're not done, don't worry, because you can come back to it. All right. Once it's uploaded to the stream. So what I'm going to do is I'm going to move on now. All right. So yeah, let's see how we're getting on. Right, brilliant. Kobe, awesome. Well done. Just block whoever that was, block him. All right, just kick him straight out. All right, good. Right, Ashley, don't worry. I'm confused at the minute with trying to sort this live stream out, but there we go. Right. Okay. So let's go. So right, we're going to move on now. To this section here. Now, this is what we're going to do here is we're going to basically, hopefully I've explained, and you can see on this picture of the boron atom, hopefully I've explained that atoms have got protons and neutrons in the nucleus, they've got electrons around the outside. But there's a lot of different types of atoms, okay? These are known as elements and they're found on the periodic table, okay? And we're familiar with these with our previous learning. And I'm showing an example here of boron, which, as you can see from the symbol, has got the numbers 11 and 5 next to it. Now, the next part of this lesson is understanding about what the mass number is and what the atomic number is and how they relate to the atom that they are representing. So we can see a picture of the boron atom and we can see the symbol for this boron atom with two key features. You've got a mass number, which is the top number, which is the larger of the numbers. Now, you've got to be careful because some textbooks, they have these numbers the other way up, okay? I don't know why, it's a bit daft, but we should have sort of agreed on which way around we're going to do it. I'm doing it the way it's done in your exam and for your exam, but don't be worried if you see this written with the 11 at the bottom and the 5 at the top. In your exam, it will be this way. The mass number will be at the top, the larger number. The atomic number will be at the bottom. And these simply show the atomic number, which is the most important number, because that's the number that tells you what the element is. We've got these 100-odd elements on the periodic table. We can all list a few: oxygen, nitrogen, sulfur, fluorine, whatever, francium, if we want to get pretty reactive. And it's the atomic number that tells you which one of those it is. Okay, because what the atomic number does is it tells you how many protons there are in the nucleus of an atom. So this atomic number, which we can see here is 5, is telling us that boron has 5 protons, positive protons in the nucleus. Count them: 1, 2, 3, 4, 5. Okay. The mass number tells us something different. It tells us the total number of little mini particles, subatomic particles, in the nucleus. So that's the total number of protons and neutrons. Because remember, the neutrons are the other things that are in the center of the atom. So, in the nucleus. So, if we've got 11 in total in the middle, because that's what the mass number tells us, how many protons and how many neutrons, and 5 of those are protons, because that's what the atomic number tells us, 5 are protons, then hopefully you can see that there must be 6 neutrons, because 5 protons plus 6 neutrons equals 11 in total. The mass number tells you the total number of protons and neutrons in the nucleus. so you can work out the neutrons. There's a bit of maths involved, isn't there? You've got to get the mass number, take away the atomic number, and you've got your number of neutrons. Okay, so there's another thing that this atomic number tells us. For a neutral atom, okay, and we'll come to ions at a later date, but for a neutral atom, neutral meaning one that hasn't got any overall charge, okay, it's got some pluses in here, and it's got some minuses, but the pluses and the minuses cancel out, so it's overall, it's not got any charge, it's neutral, okay? So, for a neutral atom, this 5 tells us also how many electrons there are. 1, 2, 3, 4, 5. Because for a neutral atom, the atomic number tells us the protons. If it's 5, it's boron. And we'll come to isotopes in a minute. It also tells us how many electrons there are orbiting the nucleus in the different shells. Okay. Right. So that's what mass number and atomic number show us. Remember, it's all in this document, right? Atomic number, mass number, it tells you here the information. You don't have to remember it. It's there for you to help you. It even tells you which one's which in terms of representing the atoms. Okay. Oh, what have I done? Right. Come on, computer. Don't crash. I think one of my shortcut keys sends things to print in Word. When really I just wanted to switch to PowerPoint. Right, hopefully you're looking at this PowerPoint. Right, so now what I want you to do, can you complete this part of your worksheet or jot it down if you've not had a chance to print the worksheet out, because this is just making sure that you know what these things are showing, okay? Use the information on the document earlier on to do that, please. So can you fill those gaps in? I think on the worksheet you've actually got some numbers, so it's this part here. I want you to do now, so it's this section here, please. If you can do that now, please, that'd be great. And I'll turn the chat on and make sure I can work out when we're all done. Bye. Come on. No, I didn't turn it off, did I? Right, good. So we're all... Right, hi Melanie, good. So we've all, I'm taking it, we've all got this done. I thought I'd not disabled it, had I? So that's fine. All right, excellent. Right, good. Okay. It looks like we're all... Right, Cameron Dent, well done. Doesn't, well, if that is for Cameron Dent. Anyway, right, I forgot to mute the live chat, so I'm taking it that we're all done, which is good. So, I'll turn it off now. Okay. Right. Let's have a look. So, right. So, I'm going to quickly run through the worked example and then get you to crack on with it with another task, because I just need to check that you absolutely understand what the mass number and atomic number are showing us. So, there's a couple of these for you to fill in. if we look at the document, I've given you these: boron, nitrogen, lithium, oxygen, and fluorine to do, to make sure that you're happy with what is being represented by the mass number and the atomic number. So, as we've said, mass number, top one, which is 11. Atomic number 5, which is the bottom one, smaller one. Neutrons, 6. That's because we've got 11 in the middle altogether, 5 of which are protons. So we've got 6. Protons, 5. Electrons, 5, because this is a neutral atom. So, can you now work through this task, please? Again, I'll leave that on the screen, because if you haven't got this printed out, you can just jot these down quickly, okay? And we'll see how we go. So yeah, get those done now, please. I'm going to turn the chat on if anyone's struggling, but I'm going to ask the moderators to keep this just about questions about whether this is, about this particular task. So blast through this if you can do it and you've got it. Remember, use the worked example. If you're struggling, like I said, send me a message, but I want the moderators to remove any messages that aren't related to if people can do these questions or not. So I'll get the chat back on. And if you've got any questions on that stuff, let me know. I'm going to give you, because we've got about 14 minutes. No, we started the lesson at 11, so we've got 20 minutes left in this lesson, but quite a lot still to do. So I'm just going to give you 3 or 4. Right, brilliant. So Hoffenbach is nitrogen 777. So let's. How do you find protons and electrons? Right, brilliant. Yes, so you are right, Poppy. Nitrogen is 777. So if I pull us, if I go back into here, right, you've got the atomic number. So we're looking at nitrogen. I hope you can see my cursor. The atomic number is the bottom number, and that tells you the number of protons. And for a neutral atom, that's the number of electrons also. So protons would be 7, because that's what the atomic number says. And the electrons would be 7 also, because it's a neutral atom. Neutrons, as was said, would also be 7, because if you've got 14 altogether in the nucleus, that's 14 protons and neutrons. We know 7 are protons. That leaves there to be 7 more as neutrons. Okay? Hopefully that makes sense. What are any more questions? I'll get back to the chat. I could only do an hour of this before my brain melted, by the way. It's not the science, it's the plumbing, operating the encoder and making sure I'm doing the right thing. Okay. Right, Kira. The atomic number fundamentally it tells you the number of protons, and in an atom that is neutral, that is the same as the number of electrons. So fundamentally, yes, in a way, the atomic number tells you how many protons, which is the same as the number of neutrons. So, for example, like we said, nitrogen is 7. So we've got 7 protons in there, because that's the atomic number of nitrogen, and 7 electrons. Yeah, well done, Poppy. So it's good this that you have. So well done, Emily. We're getting this done. Right, good. Let's have a look. Right, good. Okay. Good. Right. So, right. Thank you for that, Alex. I need to try. For the next live stream, I'll try and change the settings. I wonder if I can do it midstream with that, but I might crash the entire thing. I'll leave the settings alone, mate, while we're in the middle of this. But I will try and get the settings so you can see my cursor better for the next one. Thank you for that feedback. Right, okay. So lots of people have done this, so this is good. So we're going to move on to isotopes. So what I'll do is I will. That's fine. So we have got 16 minutes left of this lesson, but you can catch up on it whenever you need. If you need to go right. Let's have a look. Okay. So I'm gonna knock the chat off, and we're gonna look at isotopes, and I'll knock chat back on because this is probably the most a bit the thing that's a bit more difficult. Okay. Right. Let's have a look. Right. No, we're not. I'm going to show you this dead quickly. There's a brilliant website to practice this and help you get your head around the structure of an atom, and it's by University of Colorado. And I've sent you the link in a message that I gave you, that I sent you this morning. Okay, I'm just going to show you this because this is fantastic. Now, if I don't know how people are operating, but if you can have a go at this, it's fine. I won't give you a chance to look at it now. I'll just run you through it, and then after the live stream, you can get on it. So basically, if we look at what's going on here, if you go to YouTube, so you should now be able to see what I'm doing. If you go to YouTube sorry, not YouTube. If you go to Google, which I can do now, and you search up FET simulations. Now I hope I'm not blocking that. And you go all simulations, and like I said, I've sent you this link, and you go to build an atom, which is here. You end up with a program you can look at, and it works on phones. This is it's really good. You can look at two sort of simulations, and then there's some games to play. The symbol one is the one that I think is the best for looking at what we've done. So if you go into that, you get some protons, some neutrons, and some electrons, and you can basically add them to the model. So the cross is representing the nucleus, and you can add some protons and neutrons to the nucleus. Okay. Now, you can add some electrons to the shells around the outside. So this is reinforcing where the particles belong. And it also tells you when you have achieved a neutral atom. So if you look next to the atom, because you can't see the cursor, you can see a neutral atom. So this, again, is a really good thing to do to build some different atoms. Okay, so for example, if we keep adding some extra protons and some extra neutrons, so let's make a classic lithium atom. Now, it's not an atom at the minute because we've got more protons, more positive protons than we've got negative electrons. So if we've got 3 positive protons, we need 3 electrons to get the atom. So if you look at the symbol that's on the right-hand side, you can see now that the mass number has gone up to 7 because you've got 7 in the middle, and the atomic number's gone to 3 because this is you've got 3 protons in the center, and the atomic number tells you the number of protons, which indicates what the atom is. If you've noticed, I can add neutrons as much as I want, and it stays as lithium. Okay, the number of neutrons, yes, it's changing the mass number. There's 10 in the middle now, so the mass number is 10 in total. Now there's 11 in the middle, so the mass number goes up to 11. But the type of atom, the element that it is, doesn't change, because that's down to the number of protons. That's down to the atomic number. It's why this bottom number, the atomic number, is so important. If you add or take away a proton, it changes the atomic number, and that changes the element that it is. So I want you to have a look at this symbol game and just build yourself a few atoms to get practice at the structure of them, basically. Now, again, for challenge, for those who want to go further, look at the games, have a good look at this website, look at the different options, look at atom, look at the games, try and work out what an ion is. We'll go through it at a later date, but there's lots in there for you to master if you wanted some extra challenge. Okay. Right, good. So that is definitely worth going on. Back to the PowerPoint, because we'll try and round this off in the next 10 minutes. Right, last learning objective. So we'll have a quick squiz actually at our learning objectives. Describe the structure and properties of the atom and its constituent parts. Yes, we've had a look at that. We know about the protons, neutrons, electrons. We know where they live. We know their charges. We know their masses. So we've knocked that off. Describe an atom using its mass number and atomic number. So hopefully we can do this with the mass number. I can just look at the mass number and the atomic number. I've just had a funny message. Very unprofessional of me. And interpret those symbols, interpret the boxes that look like this, where we've got the bar on 11 and the 5. Okay, so I think we've done well with this. So this comes down to this last learning objective for the last 10 minutes, which is what an isotope is. Okay, so let's have a look at isotopes. Now, on the PowerPoint here, you can see that there are 3 different versions of an atom called helium. Okay, now the important thing, and that's what an isotope is essentially. Okay, it's a different variation, okay, on the same element, because it's got a different number of neutrons. Okay, it's the same element because it's got 2 protons. The atomic number, if you look at the bottom number on each of these 3 helium atoms, it's 2, because there's 2 protons in the nucleus of each of these different helium atoms. Why are they different? Because they've got different numbers of neutrons. The first one's got 1 neutron, so 3 altogether, so mass number 3. The middle one's got 2 neutrons, so 2 neutrons and 2 protons. That would give a mass number of 4. And the last one here has got 4 neutrons, 2 protons, so a mass number of 6. So these are different atoms. In terms of their structure is different, they have different numbers of neutrons, but they are the same element because the atomic number, the number of protons, is the same. Because remember, I've said it about 100 times, it's the number of protons that dictate what the atom is. Okay, so an isotope is just a different version of an element that has got the same number of protons but a different number of neutrons. So here we have 3 isotopes of helium. Helium-3, helium-4 and helium-6, all with 2 protons but different numbers of neutrons. Okay, now there's a guy that's really good at explaining this, and I'm not gonna play the video, but I'm show you where the video. I'm going to show you the video, and you've had a link sent to you. So if I go into there, I'll try not to comment on everything I do. It's me trying to get my brain working. So I'm hoping now you can see this video, this guy in a green shirt, and saying what is isotopes. You have the link. The link is there also. But if you just search isotopes, and you can get to watch this, and he explains this really well. He explains what an isotope is really well, about how it's a different version of an atom with the same number of protons but a different number of neutrons. So atomic number the same, different mass number because you've got different neutrons. Okay, so back to a task for you lot, and this should get us to finish off. Okay, I want you, if we look at a document that we've got, the worksheet that I sent you, we've got this these three isotopes of carbon. Now, I just want you to do exactly the same thing. I want you to fill in what the mass number is, what the atomic number is, how many neutrons, protons, and electrons, as you did before. But then I want you to have a go at answering. I can't scroll in a PowerPoint, Mr. Barnes, but I could scroll if I was looking at the document, which you should now be looking at the document. Good. So I want you to have a go at these 5 questions. Okay? Question 5 is pretty tricky, but there we go. So there's 6 minutes left of this live stream, although I might extend it a little bit. So I want you to have a go at those questions now, please. I'll switch the live feed on, the live chat on, so you can ask me questions about this task 3, about what isotopes are. Okay. Right. So get cracking on that, please. There it is on the PowerPoint for people who haven't. If you haven't got it, just have a look at it. Have a look at it there, and you can jot it down in your book. I will. Okay, right. Good question. So while I'm now looking at my live stream, check your email, sir. Right. I'll try, but I'm already multitasking way beyond my abilities. So now, right. Right. Check my emails. Okay. Right, I've checked them. Right. Okay. So you can't go on the chat if you've not got a YouTube channel. Right. That's fine. I apologise. Right. So here we go. I've got some questions here, so I'll keep going through these. Right. Black Sabbath, I'll come back to the stuff about why different isotopes are more dangerous, because we actually get that's about radioactive. Some isotopes are radioactive, and they've got unstable nucleuses, and that's where we're going with lesson 3 or 4. Right, the number of electrons, Emily, is, you work that out by, it's the atomic number, so it's the same as the number of protons for an atom. Okay, so for carbon, each with atomic number 6, because that's what makes them carbon, they have 6 electrons. Hopefully that answers that question. Yes, so this is right. So only the number of neutrons and the mass number is different between the different isotopes. So fantastic, Lydia, I think. Right, so can we block Noam Cohen, please? Thank you. Brilliant. And can we time out Hoff and Boff for that language? Brilliant, thank you, Kobe. We got to keep this sorted because I'm answering some good questions here. This is fantastic. Go somewhere else if you want to spam, lads. Right, good. Okay, any more questions on this? Yeah, so we'll just time out Hoff and Boff, please. Thank you. Brilliant. Good. Okay. Brilliant. Thank you, Kobe. Good. So, right, where are we time wise? I'll go. We're about to midday, and that we've covered basically everything. Right, Jenny, hello. It's working. Right, good. You got some catching up to do. Right, that's a very good point, Harvey. It's what does the bottom of the sheet mean? Okay, so we'll look at the bottom of the sheet in a minute, Sophie. Harvey, in an isotope, only the number of neutrons changed, because if the number of protons changed, it would be a different element. It wouldn't be, let's say these three carbon atoms that we've got, these carbon isotopes. If the proton changes, goes to 7, then it would become nitrogen, because it would be a different element, as anonymous user just said. And really, the isotopes are just to do with atoms that have the same number of protons, so they're the same element, but have different number of neutrons. The electrons in an atom, in a neutral atom, are just the same as the protons. So it doesn't matter what isotope of carbon you've got. If it's a neutral carbon atom, it'll have 6 protons and 6 electrons. If it's an ion, that's to do with the number of electrons changing and the charge changing, but we'll come to that in a different lesson. So for now, just think that all these atoms are neutral. So basically, the atomic number tells you the protons as well as the electrons. Okay. Sophie, the bottom of the sheet, is going to be here. So hopefully you can see the bottom of the sheet now, Sophie. So you've got to come up with, basically, in those boxes that are like empty, so the dotted boxes next to the uranium, one is for you to write your own mass number, and one is for you to write your own atomic number, knowing what you know about different isotopes. So it is a higher question, I'd imagine, but it's something that, if we understand what an isotope is, there's something that needs to be the same about those two that I've given you next to my example that's done, and there's something that needs to be different. And if you stick to those rules, look at the carbons above 12, there's not one right answer. You could put in any number of different isotopes of uranium, but one thing's got to be the same and one thing's got to be different. So hopefully that helps, Sophie. Okay. Right. Good. Okay. I need to change my shortcut key for getting the PowerPoint because it prints everything in Word. Now, before we go, I hope this has been helpful. I really do. I have enjoying it. It's probably the wrong word, but it's been like pretty stressful. But I've loved getting your feedback and stuff, and hopefully you've learned about the structure of an atom and an isotope. I'm going to sign off now because we're past the hour, and email me any questions. Email me your completed sheets. Take responsibility for your learning, which you all are doing by looking at this. You're doing brilliantly. It's been great to get feedback and hopefully be able to answer your questions and stuff in real time. There's an extension. I said before that I wanted for people to be to go away and try some tricky stuff. This extension, I don't want it to confuse anyone. Just leave it. If you are not entirely 100% sure on the objectives that we've done, as we're listed on the PowerPoint, and I'll come back to those in a minute. Don't do the extension. Only do the extension if you feel that you're rock solid on the stuff. The extension is just something that will help you link stuff in with some other stuff that you'd look at in chemistry, okay? So if we look at, one last thing then, if we look at the PowerPoint, here's your extension. I just want you, because if you look at the symbol for chlorine on a periodic table, this is what you get. And it's a bit confusing because how do you have half a neutron or half a proton? And you can't, is the answer. You can't have half a neutron or half a proton. But there's a subtlety involved here, which is what's the difference between relative atomic mass and mass number. I'm going to leave it there. That subtlety is something for those who are inclined and those who want a challenge to look at. Okay. So, I'm going to say bye for now, folks. If you want to put you've been brilliant. Most of you used the chat fantastically. I think the chat's been really worthwhile. Thank you to my moderators. Thank you lot for turning up and watching this attempt at a live stream lesson. I'm looking forward to looking at it. Give me some email feedback. How to make it better. Cursor, brilliant, Alex. I'll put the cursor on, and we'll see what we're doing. I'll do one of these every Thursday at 11 o'clock. All right. Yeah. Any questions with the worksheet? Email me, and I can get you the answers back. Or you can re-look at these videos. But that is bye for now, folks. And I shall knock this stream off. Well done, everyone. See you again soon. Right. Control.